All right, so let's look at page 2 of your assignment, and it deals with conservation of momentum. And the law of conservation of momentum is really pretty simple. All it says is that the sum of all the momentum in a system before a collision or an event occurs has to equal the sum of all the momentum of that system after the event or the collision occurs. And the event could be an explosion, or it could be a child jumping on a sled. It could be two people pushing off of each other on ice. There's multiple different events that could occur here. Okay, so with this, we can just take, let's just say there's two objects, object A and object B, and we'll just use your equation for momentum, mass times velocity here. So say we have object A and object B, but we just want to know the momentum of object A before the collision, and add the momentum of object B before the collision, and then the momentum of object A after the collision plus the momentum of object B after the collision. And we can break this down a little bit further. We're obviously going to have a mass for object A and a velocity for object A, and it'll have an initial velocity since it's before. And so all I'm just taking and plugging in mass times velocity for that specific object. And then we'll do the same thing here. The mass of object A times the, the mass of object B, because now we've got object B that we're dealing with, times the velocity of object B before, or its initial velocity. And we just add those two up to get the sum of the momentums before, assuming there's just two objects, object A and object B. Then we do the same thing for the after. We have the mass of object A after the collision, which probably won't change. Unless it's an explosion or they're breaking apart, times the velocity of object A, and then this is going to be after what we'll call the final velocity. And then we'll have the mass of object B times the velocity of object B after the collision, or its final velocity. Alright, so this is just kind of the basic equation that we're going to end up using every time, and we're going to, of course, cancel certain things out and combine some things together, and I'll show you some of those examples here on page 2 of your assignment. So let's look at question number 7. A ball A of mass 1 kilogram moves to the right, and these are velocities, so we're going to give them positive and negative. So we're going to say right is positive direction with the velocity of positive 5 meters per second, while ball B moves to the left, which is going to be a negative direction with a velocity of negative 1 meter per second. After the collision, A's velocity is negative 1 meter per second, and B's velocity is positive 5 meters per second. What is the mass of B? Well, we're just going to use that equation that we came up with. The sum of the momentums before has got to equal the sum of the momentums after the event. Okay, so I'm just going to skip right to this formula here. And in this formula, I have the mass of A times its initial velocity plus the mass of B times its initial velocity is equal to the mass of A times its final velocity plus the mass of B times its final velocity. Okay, so at this point we could either rearrange the equation and solve for the mass of B, or we could start plugging in numbers. Either way, in this case I'm going to rearrange this and solve for the mass of B. Okay, so to do that, we've got to get the mass of B on one side and then the mass of A on one side. So let's flip-flop that. Let's subtract here get A on one side. So it'll cancel out and it'll move over here. And we'll do the same thing with this. The mass of B, and we'll move it over here onto this side. Alright, so this cancels out here and this cancels out there, so then we'll be left with this equation right here. So we'll take the mass of A and subtract, well, basically the mass of A times its initial velocity minus the mass of A times its final velocity. Make sure I put an A right there. Okay. The mass of B times its final velocity minus the mass of B times its initial velocity. So notice there's some kind of switching up with those, and tracking those final and initial velocities is difficult. You notice that I had to go back in and add that in right here because I actually put an I and it should have been an F from the side since that's what I subtracted. Okay, so now we have this equation here, and we're solving for the mass of B. So let's combine that over here on this side. Really, we could do it on both sides. So I just factored out the mass of B over here. And really, I could do the same thing over here. I could factor out the mass of A. Okay, on that side also. Notice on this side I have the initial minus the final, and over here I have the final minus the initial. The way it works out algebraically. Okay, so just be careful with that. Now, let's divide out the velocities here. Okay. Oops. The final velocity of B minus the initial velocity of B. Alright, so now we have our equation for the mass of B. Now let's just be careful and make sure that we plug in the correct numbers. We've got the mass of A right there to the right, and it had an initial velocity, so that was the initial velocity of A. Okay, and then this right here was the initial velocity of B. Okay, and then A's final velocity is this, so we've got to make sure that A's final velocity is here and B's final velocity is right here. Okay, and it's 5. So that's just going to help us track. So MA would be 1. Okay. And then the initial velocity of A was 5 meters per second, so we'll put 5 minus the final velocity of A, which was -1, over, okay, the final velocity of B, and the final velocity of B was 5, minus the initial velocity of B, which was -1, so minus a -1 there. Okay, so now let's do some math. So that's 1 times 5 minus -1, which would be like 5 plus 1, or 6 right there. And then this is 5 minus -1, which would also be similar to 6. So this would be really 6 over 6, which is just 1. So the mass of B is 1 kilogram. Okay. Now, intuitively, that also makes sense, because if basically what happened was their velocity switched. A was going 5 meters per second at the beginning and then ended up going -1 meter per second at the end. Where B started at -1 meter per second and then ended up going 5 meters per second. So for that to happen, if the velocities just appear to switch from A to B and from B to A, then they have to be the same mass if that occurs. So if you ever see that situation occur, you can always go, oh, they have to be the same mass. But here we did it algebraically, just in case they weren't the same mass. Okay, but in this case, they end up being the same mass. All right. So that's the introduction to this right now, and so I'm just going to I'll do the part 2 to this one.